All right, welcome. Today we are going to be code breakers. We're going to take a look at a visual puzzle and use the power of algebra to predict its future. You ready to dive in?
Okay, so here's the puzzle we're tackling. We've got this sequence of patterns made out of dots. Pattern 1 has 3 dots. Pattern 2 has 5. Pattern 3 has 7. Looks simple enough, right? But here's the real question. How many dots are going to be in pattern 20?
So, finding the next pattern, that's pretty easy, right? You can probably see that pattern 4 would have 9 dots. But imagine drawing all the way to the 20th pattern. I mean, who has time for that? That would be a ton of work. There's got to be a smarter way to do this.
And you know what? There is. To crack this thing wide open, we need to stop thinking in pictures and start thinking in numbers. We're basically going to translate this visual pattern into a language that math can actually work with. Okay, so the first step is to get organized. Let's pop all our data into a nice, simple table. On one side, we've got the pattern number, and on the other, the number of dots that go with it. So pattern 1, that's 3 dots. Pattern 2, 5 dots. Pattern 3, 7 dots. And yeah, the one we just figured out, pattern 4, that's our 9 dots. So what we've just made here, that's actually called a mathematical sequence. And a sequence is really just a fancy way of saying it's a list of numbers that follow some kind of rule. Each number in that list, we call it a term. So for us, our sequence is 3, 5, 7, 9, and so on. Now that we have this, we can really start hunting for that hidden code. All right, we've got our numbers lined up. Now the fun part begins. Hunting for the rule. This is our first big clue to cracking this whole thing and being able to predict any term we want. So the first most obvious rule we can find is something called the term-to-term rule. And it's exactly what it sounds like, a rule that tells you how to get from one number or term to the very next one. Just a simple step-by-step instruction. So if you look at our sequence, 3, 5, 7, 9, what's happening each time? How do you get from 3 to 5 or 5 to 7? Yep, you just add 2. So the term-to-term rule is super simple. Add 2. Easy enough, right?
Okay, but hold on a second. Let's really think about this. Is this add 2 rule really going to help us find that 20th term without a massive headache? I mean, I'd have to start with our last number, 9, and then add 2. That's the 5th term. Then add 2 again for the 6th, and then again, and again, all the way to the 20th. It's definitely better than drawing dots, I'll give you that, but it's still not very fast.
Think about it like this. Let's compare the tools we have. The term-to-term rule is kind of like getting walking directions. It just tells you how to take the very next step. It's great if you want to find the 5th term. But a formula? Oh, a formula is like a GPS. You just plug in your destination and it takes you there instantly. It lets you find any term you want. Doesn't matter if it's the 20th, the 100th, or even the 1000th. So one is helpful, sure, but the other one is way more powerful. So yeah, we need that powerful tool. We need a formula. A formula is a much smarter rule. It doesn't just go step by step. It creates a direct link between the number of dots and the pattern number itself. It's like a secret shortcut that lets us jump to any point in the sequence we want. Okay, so what is a formula really? Well, it's just a math rule that shows the relationship between two or more things that can change. We call those variables. In our puzzle, our variables are the pattern number and the number of dots. And here it is. This is the master key to our entire puzzle. The formula for our dot pattern is the number of dots equals 2 times the pattern number plus 1. This single, beautiful rule can unlock any pattern we can possibly think of. Awesome! We have our super powerful tool. Now let's actually put it to work and finally solve our original problem. So the real trick to using any formula is a simple idea called substitution. It just means we're going to swap out the words or the variables in the formula with the actual numbers we're interested in. But wait, before we jump in and start substituting, we have to talk about the rules of the game. This is super important. See, in math, you can't just do the calculations in whatever order you feel like. There's a specific order you have to follow. It's called the order of operations. You might have heard of it as BIDMAS or BIDMAS. The whole point is to make sure that everyone, no matter where they are, gets the exact same correct answer from the same formula. And for our formula right now, the absolute most important rule to remember is this: multiplication always comes before addition and subtraction. If you look at our formula again, 2 times the pattern number plus 1, you can see why this is so critical. If you get this order wrong, your whole answer will be way off. So multiply first.
All right, let's do this. Let's solve it together step by step. Step 1. We write down our formula. Dots equals 2 times the pattern number plus 1. Step 2. We substitute. We're looking for pattern 20, so we swap pattern number with the number 20. Now our formula looks like this. Dots equals 2 times 20 plus 1. Step 3. Order of operations. We have to multiply first, so 2 times 20 gives us 40. And finally, step 4. Now we can do the addition. 40 plus 1 is 41. And there it is. The answer is 41. That means there will be exactly 41 dots in pattern 20. We didn't have to draw a single dot. We didn't have to keep adding plus 2 over and over again. Just one clean, super efficient calculation. That is the power of using a formula. And just like that, we've done it. We took a simple visual puzzle, turned it into numbers, uncovered its secret rule by creating a formula, and then used that formula to make a perfect prediction. Honestly, that's what algebra is all about. The thing is, patterns like this are absolutely everywhere. You see them in nature, in art, in music, in all kinds of technology. So now that you know the basics of how to turn a pattern into a powerful formula, what pattern out there are you going to try to crack next?